In this video, we'll solve a system of three equations with three variables. So we have a few problems. I copied again example 1, and let's work it out step by step. So we have three equations, so I'm going to label them equation 1, equation 2, equation 3. So step 1 is copy equation 1 and equation 2. So I'm going to rewrite them again. X plus 4y minus z equals 20. 3x plus 2y plus z equals 8. Step 2, eliminate one variable. So we have to pick one variable, and we use elimination to eliminate it. And just looking at all my variables, I noticed that z has already the same number in front of it and different signs, right? Because here is -1 and here is 1. So if we add these two together, we are going to get 4x plus 6y, z is eliminated, equals 28. This is a very important equation that I'm going to come up to it. So if I counted each of these equation 1, 2, 3, this one I will call it equation 4. Now the next step is step 3, copy equation 2 and 3. So let's copy equation 2. So 3x plus 2y plus z equals 8. And 2x minus 3y plus 2z equals -16. And here is the time when students ask me, can we copy equation 1 and 3? Yes, you can. We just use 2 and 3. Step 4, eliminate z. So while in step 2, we said eliminate one variable, any variable you could have chosen to eliminate x. In step 4, because we chose to eliminate z in step 2, we have to eliminate the same variable. So when I look at the system from step 3, I want to eliminate z. Well, this time, z here has 1 in front of it, and here it has +2. So I'm going to multiply the first equation by -2, so that I will have the same number in front of z, different signs. So the first equation becomes -6x minus 4y minus 2z equals -16. And the second one is 2x minus 3y plus 2z. I just copied because we didn't do any changes to it. And let's use elimination method, which is let's add them together to eliminate z. So we get -4x minus 7y minus 2z plus 2z is nothing, equals -32. This is another equation that is going to be important, so I'm going to call it equation 5. Step 5, copy together equation 4 and 5. So I'm going to copy equation 4, 4x plus 6y equals 28. And 5 minus 4x minus 7y equals -32. And what did we get? Well, we got a system of two equations with two variables. So we can say step 6, solve the system. So we can solve the system using addition or elimination. We can do substitution and so on. But looking at the system that we have, we can directly add them together because 4x minus 4x is 0. So we already eliminated x. So we get minus y equals -4, which means y equals 4. And we found one of the variables. Not all the time is that easy. Sometimes you do have to do some algebra to end up with, to be able to eliminate them. In this case, it was just a coincidence that they ended up having the same number in front of x, different signs. So we found y. Well, now I'm going to replace this y into this equation, and I'm going to get 4x plus 6 times 4 equals 28. So this is a linear equation in x, so I can solve it. 4x equals 4, x equals 1. And now we have two of the variables, so I'm going to replace. It's a lot of work, right? Replace x equals 1 and y equals 4 in any of the three equations, in 1, 2, or 3. You don't have to replace in all of them, just in one of these three equations that we started with. I'm going to replace it in 1. So we are going to have 1 plus 4 times 4, right? I'm replacing in this. Minus z equals 20. So we ended up with a linear one. So 1 plus, this is 16, so 17 minus z equals 20. Negative z equals 3. Z equals negative 3. So what we got is 1 for negative 3 is the solution of the system of three equation with three variables. So in order to check, you have to replace these numbers in every single one of these three equations. If you replace only in one and it works, it doesn't necessarily imply that it works in the other two. So you have to check every single one of them.